Hello students, this is Professor Chalai, and in this video we're going to look at the scientific method. Now if you'd like to follow along with me, I'm using our chapter worksheets, which you can find in the resources tab under ACE. Now in the last lecture I mentioned that every macroscopic thing, like this pen for example, is made up of billions of atoms. But you might be wondering, well, how do we know that the things around us are made up of billions of atoms of different types, and the unique properties that they have depend on how they're arranged? Well, the short answer to that question is through hundreds of years of research using the scientific method. Now, the scientific method in a nutshell starts with observation. Observation we're going to define as the active acquisition of information from a primary source. Note here that we say that it's from a primary source. If your friend tells you that they observe something from a scientific point of view, that is not an observation from your point of view. So, for example, an observation might be you sitting under a tree and observing an apple falling to the ground. Now, from an observation, we form hypotheses. So we make an observation, and from those observations, we form hypotheses and make predictions. So a hypothesis, the formal definition is a tentative explanation of these observations that acts as a guide for gathering and checking information. So in this example, maybe you're sitting under a tree and you see an apple fall to the ground. Your hypothesis could be something like, well, maybe red things fall to the ground, but purple things maybe go upwards. And that will be your hypothesis. You've made a tentative explanations for the things you see. All red things fall, but maybe all purple things rise. And then the next step to verify your hypothesis would be to perform an experiment based on your hypothesis that you've just made. So an experiment is just any procedure carried out to support, refute, or validate a hypothesis. So in this example, you would carry out your experiment to either support, refute, or validate your original hypothesis of having red things fall and purple things rise. So you might drop another red thing and find that it falls. You drop the purple thing and find that it also fall, not rise. And that would, refute your original hypothesis that purple things might rise instead of fall. And over time of continual making observations, reformulating your hypothesis, performing new experiments, making new observations from those, that is essentially the scientific method. It's the cycle of making observations, forming hypotheses, performing experiment. Now, over time, after many cycles of making hypotheses, performing experiments that either refute or confirm those hypotheses, those observations that we've made before become what we will call a scientific law. So in the case of apples falling from a tree, over many hundreds of years, we've generalized this to all colors of things, all manner of things that are attracted to the earth. That phenomenon becomes known as the law of gravitation in this case. But a scientific law just summarizes a vast number of observations. And that would be experimental observations. No, this might be very different from what we might think of as a law. A law is not some unbreakable truth about the universe. It's just a summary of all the observations that we've made over countless experiments. Similarly, after countless trial and error and fine-tuning, if you will, through experiment, hypotheses over many, many trials become what we would call a scientific theory. So theory is not just some idea that someone has sort of thought, came up with to explain how things work, but theories are just hypotheses that have been refined over many, many trials and many, many experiments. So a theory in this example is a well substantiated, it's a comprehensive and testable, that's also important, explanations of particular aspects of nature. Which comes from the hypothesis that have been refined over many, many trial and errors, many, many experiments. So that in a nutshell is the scientific method. We start with an observation. We form hypotheses from those observations. Those hypotheses must have testable outcomes. And so we perform experiments from those hypotheses to either confirm or refute them. And if they're confirmed or refuted, we fine-tune our hypotheses and we perform more experiments. After a long time, those observations become known as a scientific law. And after a very long time, those hypotheses become what we call theory in science. Law then are just a summary of vast number of observations, whereas a theory is a well-substantiated, comprehensive, testable explanation of why things happen, why the observations that we see happen. So based off of that, let's spend a couple of seconds answering number 2 in your worksheet. Which of these statements best explains the difference between a scientific law and a theory? Is it A, a law is truth and theory is mere speculation? Is it B, a law summarizes a series of related observations, whereas a theory gives the underlying reasons for them? Or is it C, a theory describes what nature does, while a law describes why nature does it? You can pause the video here while you think about it, and then I'll go over the answer afterwards. So if you've come up with the answer that a law summarizes a series of related observations, while a theory gives the underlying reasons for them, that would be correct. From a scientific point of view, based off of the scientific method, this is what a scientific law is, and this is what a scientific theory is. So that brings us to the end of our video on the scientific method. I will see you in the next video. Bye.